In this video, we're going to go over time value of money, future value of an annuity. In accounting, an annuity is a series of payments, all the same amount, spaced evenly. If you're using amounts that are not spaced evenly or amounts that are not the same, you'd have to use the future value of $1 technique, assume that they're all different payments, and then add them together at the end. But in this example, we're saving $500 per month. At the end of the month, I'll show you in a moment what happens if it's at the beginning of the month for a down payment on a house. Your annual rate is 6% and you're saving for 4 years. How much money will you have in the account at the end of 4 years? So to solve this problem, we're going to use the future value function in Excel. So right now I'm going to click on cell B12. I'm going to click on Formulas, then Financial, and I'm going to scroll down until I see FV. So in FV, the rate is our I, so it's going to be the annual rate divided by the frequency. So in the rate box, I'm going to click on cell B8, the annual rate of 8%, and then I'm going to / and I'm going to click on 12, the frequency is 12, cell B9, for the number of months in a year. For N per, if you're going to do something 12 times a year over 4 years, you're going to do it 48 times total. So in the N per, I'm going to click on B10, the number of years, and multiply it by B9, the frequency, and notice how Excel calculates 48. Now I'm going to click in the PMT box. In the PMT box, PMT is the payment made each period. So I'm going to type a negative sign because we're making this payment. We're putting it into a savings account. We're spending money. So negative, and then click on the $500 monthly payment, cell B7. Now, if you were saving this money at the beginning of the month as opposed to the end of the month, all you'd have to do is in this type box, put the number 1. Notice when I put the number 1, the answer is going to change. So it changed by about $100, but I'm going to backspace and leave it empty. So leaving type empty assumes that the payment is at the end of the month. Putting a 1 in the type assumes that the payment is made at the beginning of the month. So you would have $27,048.92 to put down on your house. Now, to calculate the interest earned, what we're going to do is we're going to take the future value and subtract what we put into the account, because everything that we put into the account plus the interest earned is the future value. So I'm going to click in cell B13, going to type an equal sign. I'm going to take the future value and then subtract what we put into the account, which is $500, cell B7, multiplied by 4 years, multiplied by 12 payments per year. So that's what we put into the account, $500 multiplied by 48, and we get out $27,000. We have earned a total of $3,048.92 over the 4 years. Now let's amortize this loan, and we know we're correct if we come down to a future value of 27048.92. So for period 0, the ending value for period 0, the ending amount is 0. So in cell E17, I'm going to type a 0. So now in cell B18, I'm going to tell Excel that the ending amount period 0 is the same as the beginning amount period 1, or the ending amount any period is the same as the beginning amount the next period. So in cell B18, I'm going to type an equal sign, and I'm going to click on E17. Now I know we're going to earn interest on 0. The amount is going to be 0, but this way if we put the formula in here, we can copy all of month 1 and then copy it all the way down to the bottom of the amortization chart. So I'm going to use the principal times rate times time formula. So I'm going to tell Excel to take the beginning amount, multiply it by 6%, and divide by 12. So in cell C18 equals, click on B18, the beginning amount, multiply it by the annual rate of 6%, and again, because there's only one 6%, it is vital to put in those dollar signs. You can either type them in, use your F4 key, or Command T if you're on a Mac. Principal times rate times time, so we're going to / and divide by B9, and the same thing, the B9 must be a $B, $9, and if it doesn't work, you can always type the dollar signs. So now we have beginning amount multiplied by our interest rate divided by our time factor. Now we're putting $500 a month into the account, so equals, click on the $500, click on cell B7, and again, that must have the dollar signs. It will not work without the dollar signs because we want to make sure that it stays $500 at all time. So at the end of the month, we're going to have $500. So for our ending amount equals, we can just sum up B18 to D18. I don't like to use the auto sum function though, because some students will include the period number with that. So you can either take the beginning amount, add the interest earned, and then add the monthly payment, or type out equals sum, open the parentheses, and make sure it's the beginning amount plus the interest earned plus the monthly payment. So now the second month will start off with $500. We'll earn interest on $500 and then put another $500 into the account, and the computer is going to model that all the way down to 48 months. So now I'm going to double click the fill handle, and again we're right if we come down to 27048.92, 27048.92.